All right, in this problem we're using summation notation, and this is just sort of a simple problem where we try to understand what the summation notation means. We have an expression 2i minus 1, and what I'm going to do is just copy that down, but I'm going to leave a blank space where I goes. And what I'm going to do is then I put in I as 1, and then I'll put in I as 2, and then I is 3, and then finally I is 4. So I changes starting at 1 and goes to 4. Let's mix up the color there. 1, 2, 3, 4. And then it's just, simplifying. I tried to pick a small number so it wouldn't be too bad. 2 minus 1 is 1. 2 times 2 plus 1 is 5. 2 times 3 plus 1 is 7. You know what? I started copying these down wrong, which I'm sure many of you have noticed. It's 2i minus 1. I started doing 2i plus 1. So that led to all these wrong numbers. 2 times 1 minus 1 is 1. 2 times 2 minus 1 is 3. 2 times 3 minus 1 is 5. 2 times 4 minus 1 is 7. Add those up. Let's see, this is 4. This is 12. So the final answer will be 16 on that one. The next one is just, I tried to make something which I thought was more fun, but that's debatable. Is this fun? I'm going to copy down the formula cosine pi over 2 times I. Well, I start off with I is 0. Then I'll have cosine pi over 2 times 1. Cosine pi over 2 times 2. Cosine pi over 2 times 3. Cosine pi over 2 times 4. Is it too much? Yeah, why did I make this so many? But I think it's going to be okay. Cosine pi over 2 times 5 times 6. Cosine pi over 2 times 7. So this is going to make cosine 0 plus cosine pi over 2 plus cosine pi plus cosine 3 halves pi plus cosine 2 pi plus cosine 5 halves pi, cosine 3 pi plus cosine 7 halves pi. That might seem like a terrible amount of stuff, but actually this problem, if we look at the unit circle, turns out to be not so bad to evaluate those numbers. So let's see how we can do that. If I can get that circle drawn. Okay, at 0, I have 1, 0, and keep in mind that cosine is the first coordinate. At pi over 2, I have 0, 1. Cosine is the first coordinate again. Pi, I have negative 1, 0. 3 halves pi, 0, negative 1. 2 pi is 1, 0. And what else do I get? I get 5 halves pi, same coordinate, 0, 1. And then 3 pi is negative 1, 0. And then 7 halves pi is 0, negative 1. So when I add these up, I get, I'm just going to actually just go through these points. 0, I'm just going around and getting the points. And what I do is I get the x coordinates. So cosine 0 is 1. Then cosine pi over 2 is 0. Cosine pi is negative 1. Cosine 3 halves pi is 0. Cosine 2 pi is 1. Cosine 5 halves pi is 0. Cosine 3 pi is negative 1. Cosine 7 half pi is 0. And what does that give us? We see that we have canceling. 1 minus 1 is 0. 1 minus 1 is 0. Aha, the whole thing's equal to 0. So I thought that was sort of good. Good problem there. Okay, so that's a reviewing of summations and a little bit of trig thrown in.